So I'm recording now. So if you are missing it, typically by the next day, I'll get the recording uploaded because it's going to save to my computer, and then I need internet. And where I live, I have terrible internet. Um, so I'll upload it, and then you'll get to see whatever I did during that time. The disadvantage of that is you don't get to ask questions, and you don't have real-time lecture or real-time work. So for those of you who maybe were signing up for a grounded class and an in-person class, and now you're stuck here because it's the only option, you might want to be here because this works for you with your learning style. So I have an iPad here. I'm going to be able to write, and you'll be able to see my board. I'll be able to switch to images and stuff and videos on my computer. So this platform works really well for doing this. So we should be able to have the same experience here as we do in class. I have a whiteboard. Now it won't meet nearly as often. I'll do one chapter in one session, and I'll do that once a week. I'll just do each chapter, boom, 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 boom. So it doesn't mean that you shouldn't be doing your work on your own or reading the book or doing all the stuff ahead of time. Do not depend on learning from me here. Learn on your own, and then let this time be refortification of what you're learning, and have things settle in and be more and grow in your confidence in it. So that's the idea. Now this is, this is Chem 100, so it's really basic chemistry. We're not going to go too deep into stuff. The hardest chapters to me is chapter 2 and chapter 6. Chapter 2 is all about unit conversions and doing dimensional analysis, which seems to get people caught up quite often. And then chapter 6 is inorganic compound nomenclature. So you're going to learn how to name the compounds. Now, many of you are probably going to be taking Chem 121 next, or some other chemistry after this. And the truth is, in that chemistry, you're going to do everything that I'm doing now again in like the first couple weeks, and then they'll go farther and you'll do more stuff. So having learning today and learning in this class builds a foundation that'll give you more confidence and ease in the next class, so that you can receive new information more readily. One of the things that I know happens in chemistry, and why people have a bad experience of it, is that you go on without understanding, and you don't stop the teacher or stop to make sure you understand what's happening and why something's being done or how to do a problem, because it all builds on each other. We're going to build a language. You're gonna by like the 7th class or 6th class or 5th week or whatever, I'll be speaking and you'll understand what I'm saying where you wouldn't understand what I was saying today, because it's going to build. So that's important. Chemistry is a science that it's like its own language, and if you don't know it and if you don't learn it, you can't speak it, and if you can't speak it, it's obvious that you didn't learn it. So it's really difficult to pretend that you know it. It's also really easy to see when people are cheating, because they can't demonstrate their work, or they show exactly the same mistakes as someone they're cheating from. So these are the kind of things that happen in an online class, because people think that it's online, well, they can cheat and they can kind of cut corners. You can, is the truth. You can do whatever you want really out there. No one's gonna stop you from doing that. I certainly am not going to invest my time and energy to help you be honest. That's not my purpose. I hope you do for your own good, because it's your money. You're paying to learn something. I'm getting paid to be here. So it would be smart to actually get what you're paying for. Now, that's not always the case with some people. So people have other people paying for them. They get involved in school for the wrong reasons, and then they just cheat, and life catches up with them, and eventually they learn. So I've surrendered to ever trying to stop someone from cheating. Unless I see something that's obvious, I will point it out, and I'll ask you. I'll say, look, this looks like this or that. I have the right to give you a 0 if I feel confident that you're not that you're cheating. So the school will always favor with the teacher's assessment of the situation. So it's not a position you want to be in. So I recommend you don't do it. I mean, most everything you can do is open book, but you do have to learn. And that's the point of being here. So when I do exams, when you do exams, when there is problem solving involved that requires actual written work, I'm going to need to see that written work because, you know, like on one of your exams in chapter 2 or one of your assessments, it might be a conversion problem to go from centimeters to like nanometers. And, you know, real easy, get on Google. You go, you know, 2.54 centimeters is how many nanometers, and Google gives you the answer and the conversion thing, right? And then you put your answer in and it'll be right on the exam. You'll get it right. But then I'll go in after that and I'll go look and I have one screen open where is your work that you've submitted that shows me you're doing dimensional analysis on it. And then another screen with your exam. And I'll check if you did the work. If you didn't do the work, I'll put a 0 in on your correct answer. So, so I'm saying that out loud here, and it's written on the syllabus and it's written in the program on the exams. You must show me your work. I have to see how you're thinking and what you're doing to get to your answer. Otherwise, it's not, you don't get any credit. So, so that goes for everybody. If there is a situation where there's no work, then there's no work and your answer is correct. And if you can demonstrate that, that's fine. But anyway, so that's the like honesty policy and how I manage that. Other than that, this class is, I've really made it pretty simple. You know, you go module by module. There's homework due every week and there's a quiz every week. That's it. That's all there is to do. One quiz a week and homework every week. There's no project. There's no discussions. Anything else we create, I'll do just to add to the class to make it more interesting or to help people learn better if I do add another element. But as far as the points you're going to earn, those are the things you're required to do. So every Monday night at 11:59 p.m., your stuff's due. That's all there is to it. If you have questions, you can write me first, and please be specific. Say homework problem number this, edition number this. Now, I don't know if people are buying books anymore because of the free PDF, but sometimes people have different editions, and that's why we have all the different homework problems for each edition. So you don't have to do all those homework problems. You just have to do the homework problems of your specific edition, like I wrote to you. So be specific when you write me. Say problem number this in this edition. I don't understand, blah, blah, blah. And then I could write you back and help you. Now that's the kind of thing I prioritize in my day. I'll get a notification. I do other work during the day, so I'm not always like right there with the book in my hand and able to respond to your question. But if you give me the info and you maybe even write out the question, I can actually answer you on the fly wherever I am with my phone. I'll just talk to my phone, say blah, 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 blah. And then that'll help you, you know, so you can get timely information if you set me up for it. Otherwise, it takes a little bit longer. I got to sit down. I got to get to my computer. I got to open up the book. I have to look up what you're looking at, and it takes me longer. So I ask you, if you want help, to do it that way. If you do it the other way, you'll still get help. It just takes a little while. In addition to that, this time, we can change when this starts if it works better for people at different times. I'll put out an announcement and a survey of some kind, and everyone can comment on the best time. I'll take the one that works the best for everybody. For the most people, I'll put a couple options up that work for me, and then everyone can choose them. Whichever one gets the most hits on the time between the 3 classes, so you're not going to see everyone's vote. So I have 3. I've invited 3 classes to this meeting. There's 24 people in each class. There's only 14 people here. So this is going to be where we get a lot done, and you know, you get to take advantage of that. So whoever responds, whatever information that is, I'll use that and I'll choose that time. And it'll typically be about an hour. You know, I can go a little longer, but an hour's, I think, all I really need to go over a chapter. So if there are questions. I'll always start with questions. So come ready with your questions. Hey, I don't understand this. Can you explain this? The video said this. I don't get this. Start with your questions. Be prepared for your questions, and I'll just do them. I'll just, until everyone's questions are answered, I will answer every question. Everyone gets the benefit of other people's questions, and then I'll move on to whatever material, right, to cover. So that's how I'm going to do this. I think at this time, whatever makes things easier for people is worth doing. And to me, this is what I can do as a teacher to help make your way a little easier with everything else going on. So I hope this helps you, and I hope that people show up and make it worth it. And I hope you can interact and participate. So to participate then, so the etiquette's going to be, I start with everybody muted when I'm talking. Then when I'm teaching, I want to know that you understand. So I might ask for you to nod your head if you understand. So I'll see the heads nodding. So do you understand? Yes, I understand. So I can see your heads, and that's feedback. I'm like, okay, we're good. We're going forward now. I got this. We're going to keep going. I'll keep talking. If someone needs me to stop, go ahead and raise your hand. Just say, stop, please, stop. And then I'll stop. And this is why it's important to have your name. Thanks, Tony. You put his name up there. Right on. So if Tony wanted to talk, he could raise his hand. Tony, why don't you do that? So raise your hand, Tony. All right, hold on. I'm going to talk to Tony. And then, Tony, can you unmute yourself by yourself? Do you know how to do it?
Can you hear me?
Yeah, I can hear
me.
Can everyone hear Tony? Thumbs up. Thumbs up. Everyone hears Tony. See, this is good. We got some communication going on here. Tony,
Right on.
what are you going to school for?
Physical therapist assistant / kinesiology. Yeah.
All right. Who just showed up there? You got to put your name in. What's your name here that just showed up and turned on your video? Yeah, you. We'll give her a second to figure it out. So listen, there's a couple views. I don't know. Some of you might be watching this and it's just whoever's talking is all big, right? There's a gallery view also that you can do, and or a speaker view. So if you're in a gallery view, you can see everybody, right? If you're in a speaker view, then you just see me or whoever's talking. Okay? All right. Oh, Catherine. Hi, Catherine. What are you going to school for? You have to unmute first.
I'm not sure. I'm just doing my general stuff right now. Kind of getting my prereqs out of the way.
All right.
I'm looking at Bellevue College. They have a radiology therapy program. I'm kind of just taking their prereqs right now.
Okay.
Figuring it out.
Well, welcome to the class.
Thank you.
Yeah. Is anyone here going to nursing school? Raise your hand. All right. Hannah, unmute yourself. Hi, Hannah.
Hi.
Hi. So tell us about you. You're going to nursing school, or what are you doing?
I'm gonna go to nursing school, yeah.
All right, at Pierce? You get into Pierce?
I'm doing my prereqs right now, and then I'll see from there.
All right, awesome. All right, well, see how that works. Everyone can talk, everyone can share. We can go around. If you have a question, you can stop things. You can say, hello, hold on, stop, and I'll stop, but I need to be able to see you. So iPhone 4S, Jillian, Jocelyn, Michaela, I can't see you. Yasmin, Amanda, I can't see you. So for you to participate, you're gonna have to turn on your camera so I can see you and stop. So maybe you're in a room where you don't wanna have, things seen, that's fine. Hi, what's your name?
I'm Michaela.
Oh, Michaela. Hi, Michaela. Well,
Hi.
thanks for showing up. Appreciate that. What are you going to school for?
Right now, I want to go to school to be a physical therapist.
Awesome.
Yeah.
Well, it's a great time to be serving people, isn't it? I mean, you can see how important our healthcare workers are right now, and how vital we all are. I'm not one. You all are. And I have a lot of respect for that. So let's get some good learning in so you can do a really good job at whatever you focus on, right? because that really matters. Okay, so everyone else, Jillian, are you going to show your face? Jillian? Yes. Does she show up? Is that her? No, that's Amanda. Hi, Amanda. Okay. I want everyone to feel comfortable to turn on their cameras because it really works a lot better. Hi, Amanda. Hi. All right, good. Do you know how to unmute yourself? On cell phones, sometimes it's difficult to work the controls. Can you unmute yourself, Amanda?
Yeah, hi.
Hi, awesome. What are you going to school for?
I am doing my prereqs for vet tech right now.
Vet tech, awesome. All right. Well, cool. So the rest of you, all right, we got another person. I can't see your name though, it disappeared. What's your name? Jillian.
My name's Jillian.
Hi, Jillian. What are you going to school for?
I'm trying to get into nursing school.
All right, awesome. Very good. Nice to meet you. Catherine, you're disappearing for a while. I saw you already. Yasmin, are you there? I'm going to call on all of you. Jocelyn, get ready. Yasmin? There she is. Hi, Yasmin. Are you hiking the Himalayas?
No, I wish.
What are you going to school for, Jocelyn?
Doing the prereqs for the vet tech program at Pierce.
Oh, cool. Awesome. All right. And then the last person we haven't seen is Yasmin. Yasmin, are you going to show up? Do you have a camera? You can talk. Shy? Not shy? Technical issues? We don't know. All right, Yasmin. Hopefully we'll get to see you in the near future. Show up whenever you can. All right, so now what I can do is, now I'm going to take you to Canvas, and we're just going to keep doing some, what was that? All right, we're going to leave that alone. All right, so now I'm going to show you Canvas. Here we go. Okay, so now I'm sharing my screen, and let's just go to the home page. So this might not be your section that I go to, but I just want to kind of go through here a little bit. So real simple. One thing I want you all to do, which is really important if you haven't done it already, is set up your notifications to get notified when there's an announcement. If you don't know how to do that, you have to go to your account here, and then so you click on your face and then notifications, and then notice all the notifications. You can get notified by email or your phone number and get a text. So I suggest you get notified for your texts anytime I put out an announcement. So that's how I'm going to communicate to the class. So if I put out an announcement, you want to definitely get it. All right. So you can set anything else up you want. You can customize what you want to get notified for and where. Okay, so that's that. So everybody do that. Now in here, so basically you just go to modules, right? And you're just gonna go 1 week at a time here. Now in this first module, I put some of these chapters in, but it was kind of like senseless. It was just from a previous class. Right here, you have the download for the 13th edition. So you can get that book. And then you see here's your homework. It's due April 13th. And there's your quiz due the same day, April 13th. So they're always due on the same time. And then I always have some video resources. And I have watched all these videos. I've chosen teachers that I think make sense and have a good teaching style that's easy to follow. I think you'll all really enjoy Tyler DeWitt. He's an excellent chemistry teacher online. He has really good illustrations. So don't ignore those. Now you don't have to watch them, but they're there for you. So the way I would do it is I would suggest you do the learning is read the chapter, then go watch the videos, then show up here. You know, do as much of that as you can. So you can see how that is set up there. And then you go to week 2, and notice here, on quiz 1, there's no work because there's no work for quiz 1. Okay. But quiz 2, there's a work assignment. So that's where you're going to upload your written work. So you want to have either a scanner or a phone that can scan. Cam Scanner is a good app. So is Tiny Scan. You know, they're not that expensive. It's just a couple bucks, I think, or you could even get a free version. So let me just see. Tiny Scan. I use Tiny Scanner. It's called Tiny Scanner. Tiny Scanner. And basically, you know, I just take my phone out. I hit plus, and then I hold it over something, snap, and you choose multiple pages, and you do one at a time, and then it frames it all, and then it puts it all into one PDF. That's how I want it, one PDF. Do not send me a bunch of JPEGs of multiple pictures that you've taken. It's really hard to grade. It opens up really big on my computer, and it's really frustrating. So please only submit PDFs or Word documents that show me your work. That's where you would upload those. So the work has to reflect the answer you put on the quiz. All of the quizzes are multiple choice. There are answers for every mistake you could make. So just because you get an answer that's on the multiple choice, don't think that you're right. Make sure you know what you're doing. Okay, because that's how I created the other options. I've seen a lot of mistakes. I know the mistakes people make. I just put all those on there. So every calculation you try, you'll one of those answers will be on that quiz. So you want to be able to do it the right way. So that's there. Then there's like extra practice problems that are in there, and then of course video resources again. So these are all YouTube videos here. And then you come down here and I have all this stuff. If it says live lecture, that means it's a recording from a class that I've taught somewhere in my past. It could have been last quarter, could have been 5 years ago at Tacoma Community College. It could have been down at Centralia. I've taught all over the place, and I always record my work. So I pick the best lectures that I think make a lot of sense and that are helpful, and I put them up for you. So if you prefer, instead of watching different videos of different topics, just watch a class on the topics. I have them all here for you, so you can just actually watch the class. And I ask people to do problems. You could do problems at your desk, come back, and then I go over the problems and see how you did. So it's sort of like that. And that's how it is throughout the whole thing. So some of the modules have more videos, some of them have less, but it goes all the way down to module 8. And then there's no more that you can see. So module 9 and 10 will get posted as we go along here. I just don't have them finished yet. So module 9 and 10 will be up. I have no issue with you going forward. For people that want to go forward and do things ahead of time, you can go at your own pace, but you definitely have to go by the due date to get things done. That's all there is. And then there's a syllabus. The syllabus just tells you, all the basic stuff, right? So we're not going to meet on campus. So you want to make an appointment if you want to meet me. I do put my phone number up here, so please don't abuse the phone number. Text me if I'm not responding for some reason to you and you have a need when you're writing on Canvas. So I always am helping people that ask for help. So if you're someone who needs a little extra help, don't feel shy. I do it a lot of different ways to help people learn. So there's like a PDF, how to create a PDF, and resources like that. Required text, you get the free one download, or there's the name of it. And here's how I'll grade based off of your average of all of those things that you get. So if you do all your homeworks, that's 10 points easy across the board, right? There'll be a final exam. And here's the live streaming lectures that I'm talking about. Weekly quizzes, dishonesty, emails, questions. And then here's basically, we're just going to go one chapter a week all the way up to chapter 10. So that's it. That's the course. If I put anything else up, you'll get an announcement about it, and it'll be a resource to you to help you learn. If I have a recording of something that I find or do, I'll share it with you and be like, hey, check this out. So that's how I'll do it. For you, when you want to ask me questions or you want to communicate something to me, just please use the Canvas inbox. And like I said, if I don't respond in like 2 days or 3 days and you're waiting for something, then you could send me a text, say, hey, I'm waiting to hear back. And you don't have to be all like, I mean, be respectful, but you don't have to overdo it. Like, dear professor, on this day, I blah, 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 and like try to be all nice to me. Just ask for what you need. It's quicker. It's easier. Just be respectful and we're all good. Okay. All right. So those are the logistics of the course. Does anybody, I'm going to switch back now over to me. Sometimes it takes me a minute here to do some of this stuff. So hold on. Stop share. There it is. Okay. All right. Stop share. Okay. So does anyone have any questions on how this course will operate? No? Nodding heads? All right, cool. So that's good. So everyone's clear how we're going to go forward. You can look for me posting the times. For those of you that are here, see, I could take a snapshot of you real quick just so I can refer to you. I'll give priority to those people that have made it for your desires. There you go. I might even do incentives to show up. You never know. We'll see. We'll see how it goes. Bonus or, cookies. No, we can't do cookies. All right. All right. So now we're going to move into chapter 1. Okay. Everyone ready? All right. Need a sip of water. All right, let's do this. So now when I share my screen, does my face still show up somewhere? Yes or no? Yes, it does? Like you saw me talking that whole time while I was showing you my screen? Okay, cool. All right. All right. So now I'm going to share this blank screen. And then we could talk about things. Okay. All right. So, so the first part here is I'm just going to talk. So why study chemistry? I'll give you my opinion because it doesn't make a lot of sense. Like a lot of things that you do here in this class, you probably won't ever do outside of school, except for a couple things that I'll tell you, you will, like unit conversions are extremely helpful. So those are practical things that you will definitely find useful. You want to be able to know how to read units. You want to be able to measure things properly and be scientific and have scientific skills to do your job properly. That's like number one, like that's the practical skills. And as you continue on in chemistry, you're going to get more practical skills about solutions and about understanding the world of chemistry a little bit more. But basically, if you look at the world, you look around you, everything is chemistry. And most uneducated people who don't understand chemistry think the chemicals are just the things that are dangerous for you, but the truth is, chemistry is it's just everything, right? So the desk you're sitting at, the walls you're in, your own body, they're all made of atoms and compounds and organized into ways that do or accomplish some purpose. So the industrialized world that we know here today has been created from this understanding of how to manipulate the atoms or molecules in the world to create things that work for us, right? So do they work for us? Yeah, I think people are pretty comfortable. At what cost do we do that? That's kind of like the humanity wake-up call now. We have a climate crisis. We have weapons that can destroy the world into, in a thought. And now, we have small little viruses that keep mutating and causing difficulties with people. And so you have to wonder, at what cost do we do and have these things, right? But that's a whole other discussion. But there's nothing wrong with the stuff, there's the stuff and what you do with it. That's pretty much all chemistry is. It's not a good or bad thing. It's just whatever you do with it. So it's important to be aware of those things, though, to be an informed person, and to make decisions about what you think should happen or what you participate in or understand information coming at you. It's important to have a foundation of learning that you can actually process information and make reasonable judgments about. So, of course, in today's climate, there's so much political jargon and things that are being said that just don't make any sense. So the scientists are out there just like, please just make sense, right? Because science makes sense. Things either add up or they don't, right? And we observe the world around us as atoms and matter, and there are natural ways things work and things that don't work. And your ability to interpret the world as real or true or just something that someone's making up is really important, I think. And getting this kind of training in chemistry is probably one of the best ways to wake up to what the world really is and how it works and what makes sense or what doesn't make sense. Either it does or it doesn't, right? And if it doesn't, you could pursue it in a scientific way to figure it out. And then ultimately it should make sense. It should be proven. It should be demonstratable. You should be able to do experiments and show that that's how things operate. Otherwise, it's not. Now I have a brother who thinks very differently than me, and he never learned the scientific method. And he never understood what a theory was. So here's sort of like how it plays out in the world. He doesn't believe in global warming. And he told me one day, he's like, is carbon dioxide toxic, Arturo? He asked me, and I was like, no, Eric, it's not a toxic gas. It's actually, you exhale it, it's not toxic, right? Well, then then why is everyone saying it's so bad? And it's like, in his world, he doesn't understand the cycles of carbon dioxide on the planet, doesn't understand how the science of global warming works. In his world, it doesn't make sense. So he can easily believe that that's not true because he doesn't get the whole picture. He's never learned it. His mind doesn't think that way. It's not systems. He doesn't have systems thinking that way. So it just doesn't apply to him. So there's this whole disbelief and reasoning that something is not real. So that is difficult, like he's not as informed as he could be. And then he said something about a theory. He said, well, that's all theory. And acted as if just because it was a theory that it wasn't good science, that it was someone's idea, right? Now in the scientific method, we know that the theory is actually, it just means that there's no evidence proving it false, which means that there's a lot of experimentation demonstrating that that's how it works. The fact that it's theory just means that you can't observe it. It's not observable as a natural phenomena that just occurs. So a theory is a very substantial thing. It's not something that someone's just making up, right? So these are things that are like part of the why of taking a chemistry class. You're going to learn how to think better. You'll learn how to evaluate situations better from a scientific mindset. You'll be able to problem solve better in any situation you have. It teaches you how to think in a scientific way. So to me, that's the most valuable part of taking a chemistry class, and that's the most valuable thing to get out of it, is do those problems earnestly, teach your brain how to think and how to solve problems when in a complicated foreign subject that may not be so easy to you. That will help you, that you will benefit from in the future. And I assure you, you will feel more confident interacting in the world and the choices you have to make with that understanding. Even just seeing the world as atoms and molecules and small particles, and understanding that these particles are all in different states of kinetic energy is like so empowering, because you can look at a situation and you could really understand that there's so much more than your eyes can see is going on, and you could be effective in that situation. So, you know, I can't say more about how important it is to have a scientific mind in the current crisis we're in, you know, because we're talking about something that nobody can see, right? And if you're trusting the news and watching and following along and being like, yeah, okay, so we can all go out, but we have to stay 6 feet away from each other, and cover yourself when you cough, and, you know, make sure you wash your hands really good, you know, but you're not actually aware of the virus and how a virus actually transmits and how long it can stay in the air and how long it can live on things. And if you don't get the science behind it, you're vulnerable to the information that you're getting. So, you know, they're like, especially today, it's extremely practical to have a good scientific mind so that you can protect yourself and your family in situations and make good choices and make good votes and make good things that will fulfill what you want for the world. So, you know, ever more so, it's important to be a good thinker. So that's what I offer you. That's what this class starts you off in as you pursue whatever career you go on. It's still important to understand the world of matter that you live in, because that's what you're doing with it all. You know, that's what you're using to work with. That's how you're going to assess a dog that is sick in a vet's office. You have to think about things from a scientific perspective. You have to be able to evaluate things and come to decisions. If you're a nurse, I mean, ever more so, you have to do that. Even if you're going into any topic, it's still a valuable asset in your back pocket. Okay, so that is my you know, my why of you know, why chemistry, basically. Why chemistry? So that's why I study chemistry. Now, the nature of chemistry, you know, the bottom line is this: we have atoms, right? These little particles. Let's call this atom A and atom B, right? And we know that the whole world is made of these small particles called atoms. And the periodic table, the lovely periodic table, is an inventory of all of the atoms that we know exist. So that in itself is remarkable. You know, imagine that you went to a new planet, you know, and you're visiting, and you're like, I'm from Earth, hi. And then the person from the other planet says, hello, here is a little table. These are all of the resources and elements we have on this planet. Basically, you can combine them in all certain ways and make whatever you want here, right? I mean, that would be pretty outrageous, don't you think? Like, here, you can make whatever you want out of this. Just go ahead. You know, you can fuel rockets, you can destroy the world. You can create medicines. You can build things that help you be more comfortable. You can do whatever you want with it. And that's what the periodic table is. I mean, that we are on that planet, right? We are on the planet where when we get here, you know, you come into the planet and they give you the periodic table of elements and say, here you go. Mix it up how you want. Let's see what works. Let's see what you can do with it, right? And that is the nature of chemistry. We are taking elements, right, and putting them together and creating something new called C, right? So you start with two different things. They transform into something else that's called C. A and B don't disappear. A and B are part of C now, right? We're just going to call it. So C, if you looked at C, C is actually A bonded to B. That's what C is, right? We just call it C, but it's actually A to B. Now, if we want to look at something more familiar, you could take like something like sodium. Has anyone ever seen what sodium metal looks like? Here, I'll show you. Here's sodium metal. It's a metal, just like other metals you might be familiar with. Where is it? Here. Okay. Can you see my page, my Google page right there? Yes, you can. I think you can. Okay, let's see. Where's sodium metal? Images of sodium. Get this out of the way. There we go. There it is. Can you see that? That's sodium there. It looks like aluminum, right? It's all shiny and brittle, or not brittle, but shiny and metallic. That's how I'd say that. Okay, so that's what sodium looks like, right? And this is what chlorine looks like. Chlorine's a toxic gas. Let's look at the gas. Here we go. There you go. There's chlorine gas, otherwise known as mustard gas. And it kills people. It'll destroy your neurological system in seconds if you're exposed to it. So that's chlorine gas, Cl2. If we go back here, right? So I have sodium and chlorine, right? Those are those two. Can't see what's going on anymore. Where are you all? Hold on one second. That way. There you go. Okay, I see you now. All right. So does everyone nod your head? Can you see my whiteboard now? Okay. And did you see the chlorine and the sodium? Okay, cool. Okay, so you see how different those are, right? Now, can you imagine eating sodium metal? Like just chew on it, just chew on some metal, right? That wouldn't work very well, right? It actually would react very strongly in your mouth because it reacts with water vigorously. Now that chlorine gas, green, toxic, you know, you wouldn't want to eat that, right? It'll kill you. But when these two react, they form a compound known as sodium chloride, right? And everybody knows what sodium chloride is, right? Nodding heads. Salt. That's table salt, right? Sodium chloride is table salt. So that's the stuff you put on, you know, your food, your popcorn, and whatever else you're using. And it is completely different than what it came from, right? So this is A, right? This is B, and this is C. So you've taken A, which had its own properties. It's totally different. It's something you would never eat, right? You mix it with B, which is completely toxic and dangerous. They react, they chemically join together and form something known as sodium chloride in a completely different structure than what the two were when they started. And suddenly you can add it to your food and eat it. So it has new properties, completely different properties. That is the nature of chemistry. So you're taking different elements and forming them into compounds, or different compounds and mixing them together to form new substances that have different properties, okay? Does that make sense? Nodding heads. Awesome. Okay, so that's the idea. Now, there are also things that that won't react, and the big difference between those things is basically how we're going to classify all of matter. So I'm going to go ahead and jump to classifying matter real quick here. So so one of the things you have to learn in this chapter is how to classify matter. So first of all, matter is anything that has mass and takes up space. So anything that has mass and takes up space is called matter. So, everything you look around at is matter, okay? Because it weighs something and it takes up space. And what we say, if something, to measure the space something takes up, we call that volume. So volume is the space something takes up, right? The mass is its weight. Now, mass is the amount of matter. Just kind of like the reverse definition. Mass is the amount of matter in something, right? And the weight is actually a force that is dependent on the gravitational pull. So when we say how much does something weigh, we're kind of assuming that it's on planet Earth, that it's under the influence of 9.8 meters per second squared, the gravitational pull, and then we'll say, oh, so many grams or so many pounds. That's how much it weighs. So weight and mass are kind of like the same thing when you're on one planet, right? Now, if we went up to the moon, and there's a different gravitational pull. Let's say we took a piece of copper, right? Let's say this is copper, and copper is made of a bunch of atoms here. Let's say it's made of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's say it's made of 15 atoms there, right? 15 atoms of copper. And we weigh that here on Earth, right? And now I'm going to make this up because it's so small that it would never weigh this now, but I'm just going to call it like 1 gram. So let's say we weigh it on Earth. It equals 1 gram. But on the moon, it weighs 0.01 grams. So on the moon, it weighs differently than on the Earth. However, it has the same mass, okay? Because the mass is the amount of matter. The amount of matter is 15 atoms. You have 15 copper atoms. They are the same. Okay, so do you get the distinction? So if you, and part of this is like, okay, I want you to think like a chemist. I want you to look at stuff like you're in the matrix, like you're in the matrix and you're looking at stuff and you're like, okay, well that's a piece of paper, right? This piece of paper I'm looking at, it's a piece of paper, but it's really not a piece of paper. It's really a bunch of atoms just sitting there vibrating, right? And then look at it until you can see those atoms vibrating, until someone in your family slaps you and says, snap out of it. But the truth is, that is what's happening, right? You are surrounded by this small little world that is made of particles that are vibrating. Even as they are solids, they're vibrating, right? And they exist in different states of vibration is pretty much all that's happening here. So when you look at it, though, and consider that it's made of particles, those particles are considered a form of matter, right? And therefore, the collection of them is the mass of that. How much matter is there, okay? So you take that amount of matter from here to somewhere that has a different gravitational pull, it will weigh differently, but it's the same amount of stuff. It's the same amount of matter, okay? So that's an important distinction. So now matter is anything that has mass and takes up space, okay? So it has to exist. Now, what's not matter in this world? Well, if you look around, anything that is made of elements or compounds is matter, right? However, there's something else going on here, and that is what we call energy, right? So energy is not classified as matter. Energy is not classified as matter. You have little lumens and photons. Or lumens are the rate of the amount of power in the light, but it's made of photons, and those are considered to not have mass, right? Now, why do I say not classified as matter instead of it's not matter, right? Why am I using this language? It's not classified as matter. It's made of these things called photons. The definition of matter is that it has to have mass and take up space, right? Well, you know, there's light in this room. There's photons here shining on me. I got a light right here, right? And whatever this is right here, it doesn't weigh anything, okay? It actually is considered not taking up space either. It's like if I can compress it and it just disappears. It's not here in this world that we understand as matter. However, I say it the way I say it because what do you think determines if something has mass or not? How would you know if something has mass? This is a question for someone to raise their hand for an answer. Here's a chance where you get to say something. What do we got here? The question is, so you're gonna have to unmute yourself. How do you know if something has mass? It's really a straightforward question. It's not complicated.
The weight?
You weigh it, yeah. And what do you weigh it with, Julian? How would you weigh yourself?
With the scale.
A scale, right? A weighing device, a scale, right? So you have to be able to weigh it. Now, how expensive do you think the scale is that weighs atoms? Is it something you could buy at Target?
No.
No, right? I mean, do you think it has to be a very complicated machine?
Probably, yeah.
Yeah, of high technology, right?
Yes.
Extreme technology, right? Now, okay, thank you. So, think about it. There was a time when we thought the Earth was flat, okay? And it was just like this table. The world was flat, and you could literally, here I am, I'm on the Earth, and I could walk off the Earth. Walk off here. Wait, hold on. Here I go. Ah! Sorry, turn that off. And I would fly off the Earth into the abyss, right? That was believed by everybody on the Earth at some time, right? Why did they believe that? Well, because they didn't experience that the Earth was spherical, right? Or whatever it is, elliptical, is, that it's three-dimensional, that you can go from one side to the other side, right? So nobody could see that. And at one time, they also thought that the smallest particle that existed was the atom, right? And it was a theory because they couldn't see it; they just knew it was there, right? So how could anyone know something's there but not see it? Well, here is tape, right? I'm gonna hold it in front of me. I'm gonna put it down here, right? And I'm gonna close my eyes and I'm gonna touch it, right? I can't see it, but it's there, right? And whenever I push my hand out, it hits it. And if I throw something at it, it deflects off of it. So I know something's here. I know something's here. So that's like the edge of science. The edge of observation is the edge of science. The edge of truth is what we observe or have reason to believe it's there based off of experimentation we do that says it's there. Well, if I keep hitting it, something is stopping me. There is something here. What is this? You know, and guess what? I don't know what it is because I can't see it, because I am limited by my observation, because I don't have a tool that can magnify that small, right? I just don't have it. There's a limit to what I can see. There's a limit to what I can measure. The limit to what I can measure is the best tool in the world that we have, how far that can measure, how precise that can, or how accurate that measurement can be. Does that make sense to you, what I'm saying? Nodding heads. So our limit of observation is what determines how much can be measured. And the limit of our observation is our technology. We have a limit to how much we can see out into outer space. And we also have a limit to what we can see inside of matter, right? And that is completely determined by the power of the instrument. So when I say, oh, energy is not classified as matter, I would never make an absolute statement like that, because there is a limit of observation. And the limit of observation is the power of our ability to detect mass. So as it stands now, we can't measure that, right? It's just not measurable. So I'm not saying that energy is matter, but I do know that in quantum mechanics, where is it? I got to deal with this situation here. I start talking and not using my board and it turns off on me. Hold on one second. Here we go. That energy somehow converts to matter at some point in waves. They say, and that's something that's like deep science, and you don't have to understand that. But the point is, there's a limit of observation, okay? And so maybe we just can't measure it yet. Or maybe something is there, but we just can't see it yet, right? So that's the context of a scientist. The context of a scientist doesn't identify anything that's absolute unless it's observed. If it's observed, it's irrefutable, right? In the context of it's real because it's observed. And that's the limit of science. The limit of science is it accepts what's observed. I'm not saying that there's not more here. As a matter of fact, I know there's more here, you know, because if you look at the trend of things being revealed, at first we were on a flat earth, right? At first, the atom was the smallest thing in the world. And now we know that there's protons, there's neutrons, there's electrons, there's subatomic particles even smaller than that, because the power of observation increased. So the take home is, you know, there's always more, right? Your kids are going to be living in a different world than the world you're living in, because there'll be more discovered. And to act as if that's not true is foolish. It's just not scientific. Science tells you that things will continue to change and you will discover more. That's been the pattern, at least, unless we revert to the Dark Ages really quickly, which sure seems like sometimes. Okay, let's see here. There's my board. Okay, so that's the context we're in. Everyone get it? Awesome. Okay, so energy is not classified as matter. So energy actually moves through matter, right? We are all are using energy that we got from the sun right now. Do you remember that whole thing? How that works? The sun, sunshine coming down on a sunny day, down to the plants, right? Here's some plants, and they're growing, and then you got those plants are food, right? Or you have some animal eat it, like a cow. I'm not going to draw a cow because I'm really bad at it. And anyways, it all turns into food, and that's energy. This has energy in it, and we take in the food energy. We make our bodies out of that energy and matter that we eat, and we use the energy that's inside that food to operate, right? And right now, I am exerting a lot of heat because I'm talking nonstop and I'm moving. So if you had an infrared light, you would see heat coming off me, right? And you would probably be a little cooler because you're not working as hard as I am. You're not talking, you're not running your system so fast, so you're not consuming all your calories, right? But if you were exercising, yeah, you'd be burnt. All that energy would be coming off you as heat. Okay, so that's energy. It's occupying matter. It's stored in chemical bonds. It's stored inside of all matter, and it can be released. So you have matter and you have energy, and that is what's happening. Okay, so we were looking at how to classify matter. So we have matter. Now, matter is going to be classified as pure substances or mixtures. So when I was telling you sodium, when I showed you that reaction between sodium and chlorine, right? There was sodium, there was chlorine, and then there was sodium chloride. Three different pure substances. So each of those is a pure substance because they retain their own identity as they are as a chemical compound or as an atom. So atoms are pure substances and compounds are pure substances. If they're alone, like water, right? If you have water, it's H2O, that's a pure substance because it's just water. Now, I can't go and try to break water apart physically by physical means. I can't drive a car into a water drop and break off the hydrogens. Okay, it doesn't work that way. I need to use chemistry to be able to take apart a compound into its atom components. Does that make sense? Like you can't do that physically. So if it's a pure substance, it has nothing to do with the idea of purity. It just, the purity part means it's all alone. It's just one substance. And that substance has its own properties that retain their properties all by itself. Okay. So iron, right? If you had iron, an iron bar that was all iron, that would be considered a pure substance. It's pure iron. Okay. Now, the difference is if you have a mixture, and a mixture is just basically a mixture of pure substances. So now let's take that salt, right? And let's mix it with water. If you have sodium chloride and water, if you take some water and dump some salt in there, did you change the water? Yes, right? It's now salt water, right? But is salt still salt and is water still water? Anyone know? Is the salt still sodium chloride and is the water still H2O? That's the question. If you mix salt with water, does it chemically change or not? Anyone? I think Jillian has a thought. Jillian, what?
At first, I would say no, it's still water, but I don't know chemically. So that's why I stopped answering that.
Okay, well, let's think about it. If you cook the water in salt water, what are you left with?
It would dissolve, the salt would dissolve into the water, right?
Right. And then, but when you heat it up, let's say you boiled all that water off, what would you be left with?
Salt.
Salt. Would it still be salt?
Yes.
Yes. And would the water that you boiled off be water when it left?
Yes.
Yes. So there you go. That's a mixture. A mixture can be physically separated into its component parts. So just because I mixed the salt with water, yes, it dissolved, but going into a solution does not change its chemistry. So only if you change its chemistry is it a pure substance on the other end. Like the sodium and chlorine went through a chemical reaction that became sodium chloride. So each one of those is a pure substance. But if I take sodium chloride and mix it with water, they don't react and form a new substance. They retain their chemical identities, sodium chloride and water. They are physically separatable, meaning if I apply heat to it, I can separate it, right? So a mixture is separatable by physical means, and it's made of of pure substance parts, right? So you can separate the pure substances away from each other. So so there you go. Another mixture example might be, which is less obvious, is the air. Air is a mixture. What's in the air that you know of? We have oxygen, right? We have carbon dioxide, there's nitrogen. Those are three big ones in the air. And they're not reacting and forming new gases. They're retaining their gas identities. They're completely mixed out here and distributed however the gases work in the environment, but there's always enough oxygen for you, it appears, right? So you're breathing in oxygen molecules. You're also breathing in traces of nitrogen and carbon dioxide, right? But majority that your body's using is the oxygen. And then you're exhaling carbon dioxide. So those are mixtures. Those are separatable also. They have devices. I mean, I couldn't do it here with what I have, but there are instruments that would collect oxygen or collect CO2, and they can be separated. Another mixture might be if you took water and put sand in it, right? If you put water and sand together, you would clearly see there were two separate substances in there, right? You would see the sand and you would see the water. So mixtures can be divided up into two types of mixtures. You could have homogeneous mixtures or homogeneous mixtures, and you could have heterogeneous mixtures. And the homogeneous one example is the air or the salt water. And the heterogeneous example is the sand and water. So the key is they're both mixtures, which means they're made of pure substances that are not chemically joined, right? They're unique compounds that have chemical structures. However, in a homogeneous one, they join in a way that makes one phase where you can't distinguish the parts. You can't see them, right? I can't go here and be like, oh, there's an oxygen molecule. Oh, there's a carbon dioxide molecule. I don't see them. They're all mixed into one phase called air, right? And then in salt water, it mixes up completely. It's all one thing. It becomes one color. It might be a little cloudy, but it's all one color. Normally, it should be clear, really, if you dissolved it all. So it would just be all one phase, right? So if it's all one phase and you can't see the parts, all one phase, I can't distinguish the parts, then, and it's a uniform concentration, then that means it's a homogeneous mixture. So you go out, you get a cup of coffee from a Starbucks or wherever, and ideally you've received a homogeneous mixture, right? It is uniform. The first, I mean, if you don't get whipped cream on it and all that stuff, let's just say it's a regular cup of coffee, right? You take your first sip, it's got the exact amount of sugar and coffee and cream or whatever you have in there in one sip, and you drink it again. It's the same concentration, same concentration, same concentration, all the way to the bottom. You grab an iced tea or cola, you drink it, it's the same concentration throughout. Those are homogeneous mixtures. You can't see the parts, you can't separate them without using some physical means. You'd have to cook them and separate the parts because they have different boiling points. But those are homogeneous mixtures. So the air is a homogeneous mixture. All those mixed drinks are homogeneous mixtures. But then you get something like sand and water, and you can see the parts, and you can easily just separate the water out from the sand, maybe dry the sand to get all that water off the sand, and now you have sand and your two separated again, right? Piece of pizza. Let's say you get like a pepperoni and sausage pizza with onions. You know, it's not uniform concentration. Every bite is different. It's certainly a heterogeneous mixture. You can see all the different ingredients. They're not all blended into one, right? Or so that would be a heterogeneous mixture. Most of nature is heterogeneous mixtures. They're combinations of pure substances that are combined in ways that give them different properties. But if you took them into the lab and you separated them all out, you would find unique compounds and unique atoms that are all mixed together forming something. So most of the stuff around you is probably a mixture. The desk you're at, the wall, the pure substances that you'll find more commonly is, the water you're drinking. Even that is probably a mixture. You probably have, depending on where you're getting your water, you have minerals in there that are dissolved. If you're in the city, you probably have residues of whatever they use to treat the water before it gets to you. So that's the difference between homogeneous and heterogeneous mixtures. So all of matter is basically either a pure substance or a mixture. And then the pure substance is either an atom or a compound. And the mixture is either homogeneous or heterogeneous. And that's how we classify matter. Any questions on that? Awesome. All right. I think that is probably enough for today, since I did the intro, and I don't want to take you longer than too much longer than an hour. So that's the part that I think is maybe the most helpful to you to classify matter. So you definitely want to go over the scientific method and understand the physical states of matter on your own. That's basically solid, liquid, and gas. If you have any questions on anything from chapter 1, be ready for next week, and you could ask those questions, or you could ask me privately. But you want to watch those videos. I'm sure you'll have good understanding from the videos. If the individual videos don't work for you, or if the lectures don't work for you, then try the other and see what works best for you. All right, everyone good? Awesome. Thumbs up. Everyone like this session? Was that good for you? Cool beans. We'll keep doing it then. So look for my next announcement with the time survey, and then we'll go from there. Have a great day, everybody. Be good to each other. Bye-bye.